Hello class, welcome to lesson 1.3 on geometry. So we're going to be talking about midpoint and distance. So the questions that we want to address today are: how are the midpoint and length of a segment on the coordinate plane determined? How do you partition a line segment in a given ratio? So we're going to be talking about partitioning, midpoint as it relates to line segments, and length, which really means the distance of a line segment. So our goals are to be able to use the midpoint and distance formulas to solve problems, and find the coordinates on a line segment between two given points that partitions it in a given ratio. So we're going to be mentioning the word midpoint and partition as the vocab. So let's talk about partitioning. So partition means to separate or divide. So when you're cutting things into parts is really what partitioning is all about. So partitioning a line segment means to break it up into pieces of certain lengths. And these lengths are usually written as a ratio or as like a fraction of a whole. So for example, let's say we have line segment AB given below, and we want to partition AB so that the point is 1/4 of the way from A to B. So basically we need to introduce a point in this line segment that essentially cuts it into two pieces, so that that point is actually 1/4 away from A and 3/4 away from B, essentially. So what we're going to do is we're going to cut that line segment into four pieces. So notice that there are the four pieces here. So we have, 1, 2, 3, 4 pieces, which really means we slice, we put 3 slices there in between. So now that we got the 4 pieces, well then we can go ahead and introduce the point. Okay, so the point would be in the first piece, in the first tick mark that I made, because now that piece is 1/4 away from A. Because remember, there are 4 pieces, and that's 1 away. And then if you look at B, well, that's 3/4 away from B. Another way of saying this is that this partition is divided such that it's in a 1:3 ratio from A to B. Okay, so this is another way to put it. So saying that something is 1/4 of the way from A to B is the same thing as saying divide it in a 1:3 ratio from A to B. Okay, so let's look at another example. So let's say we wanted to partition the same line segment, but now the point has to break the line segment into a 3:2 ratio from A to B. So that means the 3 part refers to A, because that's saying from A. So that refers to A right here. And then the 2 part refers to B. So that means the point has to be 3 away from A and 2 away from B. Well, when we break it that way, well, how do we know that there's 5 pieces? Well, when you're given a ratio, well, you just add the parts together. So 3 plus 2 is 5. So there's 5 pieces that we want to break this into. And so the point is going to be 3 pieces away from A and 2 pieces away from B. And you can see that by the given diagram, it's a 3:2 ratio, or 3/5 of the way. So you need to know how to convert from a ratio to the fraction, and then from the fraction back to the ratio, going back and forth between those two. Again, it's 3/5 because there's a total of 5 pieces here. So now that we know how to partition a line segment, given a ratio or given, a fraction, basically, we want to go over the steps for partitioning using coordinates. So we want to actually do this calculation. So step 1 is to multiply the horizontal distance and the vertical distance of the line segment by the fraction of the distance from one end to the other. So the fraction part, so not the ratio that they usually give you, but the fraction. Again, if you had a ratio of 2:3, then in that case your fraction would be 2/5, for example. That is if you're talking about, from the initial to the final. If you had a ratio of 3:5, well, then you would use 3/8 as your fraction, okay? Because there's a total of 8 pieces, 3 plus 5, and then you're using the 3. Okay, so it really depends if you're talking about 3/8 of the distance from where, right? If you're talking about 3/8 of the distance from A or from the initial point, then you're using 3. But we'll get to that when we do the example. So basically, you're going to multiply horizontal distance and vertical distance by this fraction, okay? And then you're going to take the horizontal distance and you're going to add it to the x-coordinate of the initial point. This is the point that you're traveling from. So when it says 3/5 of the distance from A, well then A is your initial point. And then the vertical distance to the y-coordinate of the initial point to get your new coordinates. Okay, so there's a lot of verbiage here. So we're gonna talk about what it really means to partition using these steps. So let's look at the line segment AB given below. And the coordinates are labeled for A and B very conveniently. So we're going to go ahead and follow the steps. Well, first off, they want to find the coordinates 3/10 of the way from A to B. So they said from A to B. So that means A is my initial point. So 4, -7 is my initial point. So that's one thing that you want to keep in mind is figure out what your initial point is before you even get started. So then step 1, multiply the horizontal distance and the vertical distance by the fraction of the distance from one end to the other. So in this case, they give us a fraction 3/10. So that's our fraction that they refer to here. So now what we're going to do is we're going to actually find this horizontal and vertical distance. So how do we find the horizontal and vertical distance? Well, what we do is we break this line segment into a horizontal component and a vertical component, just like I drew here below. So let's go ahead and find the horizontal component first. Now we know that the x-coordinate here for A is -4. And the x-coordinate for B here is 12. Remember that the x-coordinate is the first coordinate and the first number in the set of coordinates, right? The ordered pair. And so the distance in the x is from -4 to 12. And so in order to find the distance, remember that from lesson 1, that we just need to subtract the two numbers, right? And with the absolute value. So here we have the absolute value of 12 minus -4, which is going to be 16. So that is my total horizontal distance from A to B. This is this horizontal part. All right, so I went ahead and labeled that 16. So now we're going to find the vertical component. So now if you look at the y coordinates, y coordinate means vertical. The y's are vertical. So if you're going to, so here you're going to go from a y coordinate of -7, which is this guy, that's the y coordinate of -7, to the y coordinate of 5, right? Because this is going up, up and down. And so if you find the distance between -7 and 5, well, that's just going to be absolute value, 5 minus -7, and then you're going to get 12. So that is my total vertical distance. So we found the total horizontal and the total vertical. So now what we're going to do is we're going to take that horizontal, that total horizontal distance, right? That 16 that we have, and the total vertical distance, which is 12, and we're going to multiply it by the fraction that they told us, which is in this case 3/10. All right, and this is given on the diagram. So the 3/10, if you were to divide this 16 into like 10 pieces, right? I'm going to try to do this into 10 pieces the best I can. So maybe this will be like the 5th piece or something like that. So we're going to cut it in 9 places. So 1, 2, 3, 1, 2, 3, 4, 5, and 6, 7, 8, 9. So if we were to imagine cutting that into 10 equal sized pieces, well then 3/10 is, you know, is somewhere around this ballpark, right? From there to this end. And that would be about 3/10, right? So so that's what that diagram is labeling. And so this is 3/10 of the horizontal side. Okay, so we're going to take that fraction and we're going to multiply that by the total horizontal distance of 16. So this 16 is right here. So 3/10 times 16. So in order to multiply this fraction with a whole number, remember 16 is the same thing as 16 over 1. And then 3 times 16 is 48. And then 10 times 1 is 10. Okay, so that's how we got the fraction 48 over 10. Then on the calculator, you just do 48 divided by 10. That's going to give you 4.8. So that right there is my horizontal distance. Okay, so this right here, this horizontal distance in diagram is the 16. And then the vertical distance in the diagram is 12, right? The total vertical distance. This should really say the total right? Not the partial, but the total. All right, so now that we got the partial horizontal distance, or just a regular horizontal distance, we're going to do the vertical. Okay, so again, if we were to break up this line segment, the vertical part, into 10 pieces, 1, 2, 3, 4, 5, 1, 2, or 6, 7, 8, 9, and then, well, then 3 tens, 1, 2, 3, 3 tens is around there, right? If you were to count it. Well, then in that case, we're going to take the 3 tenths and we're going to times it by the 12 that we have here for the vertical distance, the total vertical distance, and that'll give you the partial vertical distance. Remember, 12 is the same thing as 12 over 1, multiply straight across, and you get 46 over 10, which is 4.6. Okay, so that's step one. Step one was pretty lengthy, but I wanted to combine it into just 2 steps, even though the steps can be a lot. So the step 2 is, now that we got those distances, we're going to add the horizontal distance. This is the horizontal distance right here, right? So the one that we found, 4.8. We're going to add the horizontal distance to the x coordinate of the initial point. The initial point is right here. This is the x coordinate of my initial point. And then we're going to add the vertical distance, which is this guy here. We're going to add that to the y coordinate of the initial point. Okay, so let me show you that in detail. So again, I circled the x coordinate for my horizontal distance, and so we're going to say x is equal to the initial x value, which is the initial x value is, in this case, is the -4, right? And then the horizontal distance is what we got here, 4.8. All right, so it's going to be -4 plus 4.8. And then we're going to repeat that. We're going to repeat that for y. So then y would be -7, and then plus the vertical distance. I'm going to use that. So y would be in green. So we're going to repeat that for y. That's going to be the vertical distance of 4.6 plus that -7 there. So let me show you that calculation. So in this case, see, if we show you the calculation, well, then x is going to be the -4 plus 4.8, which is 0.8, and then the y is the -7 that I circled there, plus the vertical distance of 4.6, which is -2.4. And that right there, folks, is my coordinate. We're going to put these together. See right there and there. Those are my coordinates for my for the point that partitions this line segment in the 3/10 fraction that we want. Okay, so it breaks it up into a coordinate that's 3/10 of the way from A to B. Okay, so and those coordinates right there represent the intersection of the 3/10 from the vertical part and the 3/10 from the horizontal part. And notice if you put those together, right? If you put those together, then you actually get the 3/10, the total 3/10 coordinate for the original line segment, if you can kind of tell. So if we were to break this original line segment into like 10 pieces, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. Well, then there you go. There's 10 pieces. This right here is 3/10 of the way, which is pretty interesting, right? We were able to calculate that just by doing the 3/10 of the way for the x side and 3/10 of the way for the y side. All right, so let's look at another example of partitioning a line segment. So again, so we got the line segment AB, and we got the coordinates here. Now this time, notice we got a fraction just like we did before, but notice now they want you to find the coordinates of the points 3/5 of the way from B to A. So this is a big difference from the previous example, right? So this time they switched the position. Now, how is that going to change the problem? So the way that's going to change the problem is, well, instead of so if you think about it this way, if you're starting at A, right, and then that means that whenever you find a coordinate after that point, you're going to be adding the coordinate to get to the next point, right? So for example, A has 3, -4. If you want to get a coordinate to the right of A, well, then you're going to have to add something to get a coordinate to the right of A. if you start at B though, and you have to be somewhere on the line segment, well, that means you're going to go to the left, and the left means that you're subtracting. And so we're going to see that in the formula, instead of adding it for the x and the y, we're going to be subtracting it. Okay, so I'll tell you what I mean by that as we get to that step. Okay, so because we're going from B to A, this means my initial point changes. So let's label this B, let's label this A. So my initial point is not going to be A, it's going to be B. So it's going to be 13, 11. So that's my initial point, it's that guy. Now we're going to do the same thing that we've done before. We're going to find the horizontal side of the line segment and the vertical side. So let's color code this just like we did before. So this is going to be our horizontal side, and then we're going to stop here. This is going to be our vertical side. And notice that we always form that right angle whenever we do this. It always forms like a right triangle, okay? So now let's go ahead and do the calculation for the distance. Well, we know that the A coordinate here, that's 3. That's the X coordinate there. And for B, this is the X coordinate of 13. So if I want to figure out the distance between the A and the B and the horizontal, I got to subtract the X values. So I got to subtract 13 and 3. Okay, so I'm going to go ahead and do that now. So we have 3, subtract the X coordinate there, and then the X coordinate of the other coordinate of the other point, and then do the absolute value. And so that's going to be the absolute value of -7, which in this case is 7. Okay, so this means that the horizontal side is 7. Now let's do the vertical side. So this time we're focused on the y coordinates in order to subtract for the vertical side. So we got to do -4 minus 11, or 11 minus -4. Either one is fine. So let's do -4 minus 11, which is absolute value of -15, which is, in this case, is going to be 15. And that's my vertical side. So I'm going to go ahead and label that here right now. And then my horizontal side is 7, which is what we said earlier. Okay, so now we're going to do our horizontal distance, which our horizontal distance is our horizontal side times the fraction. So we're going to take our horizontal side, we're going to multiply by the fraction, which is 3/5. Remember, 7 is the same thing as 7 over 1, multiply straight across, and that'll give us 21 over 5. And then we'll go ahead and convert that to a decimal. 21 divided by 5 is 5 goes into 21 4 times. So this will be 4.2. Now let's do the vertical distance. So we're going to take the 15 for the vertical side that we got earlier. We're going to multiply that by the fraction 3/5. Again, put an over 1 for 15, multiply straight across. So it's going to give us 45 over 5, which is 9. Hoping I subtracted those correctly. I actually did not subtract the x coordinates correctly. I apologize for that. So it's the x coordinate for B is 13, not 10. So I'm going to change that now. I apologize for that mistake there. And then 3 minus 13 is -10. So it looks like I kind of subtracted without even thinking about it. So, which is 10. Okay, so this right here should be 10, not 7. I apologize for that mistake. And so 10 times 3 is 30, and then so we got basically 30 divided by 5. Let's change that. Which is going to be 6. All right, so that's my horizontal and my vertical distance. So we have x equals, so now we're going to x equals the horizontal distance, which I'm going to color code these. So now this is what's going to change. So because our initial point is from B to A, I need to go to the left here. Because I need to go to the left, because I need to go to some coordinate here that cuts this, right? Then that means I got to subtract. So what I'm going to do is I'm going to subtract the horizontal distance here. So I'm going to take the initial x value. So let's go and write it out. So this is going to be my initial x value, and then we're going to subtract, instead of adding, we're subtracting the horizontal distance. And then for the y, we're going to be using the y initial, and then we're going to be subtracting the vertical distance. And that we're only doing that because that makes sense in this example. Okay, so in this example, you're going to be going left and down. And so it makes sense that you're going to be subtracting for x and then subtracting for y. Now, let's say your line segment is going down instead of up, right? Let's just pretend, just for a second, that your line segment is going like that. And this is B, and you're traveling from B. Well, in that case, you're going to be going left and up. So for the x coordinate, we're going to be subtracting the horizontal distance. And for the y coordinate, we're going to be adding the horizontal distance. All right. Remember, you're trying to travel up the line segment in this case. And in the example that we're looking at now, the original example, we're trying to travel down the line segment. Okay. So the plus or minus signs really depend on that. Okay. So that's very important. And so now if we calculate the x, well, then the x is going to be the x initial is this guy, and then this is the x initial, this is the y initial, so that's going to be 13 for x minus the horizontal distance of 6, which is going to give us 7. And then the y coordinate is 11 minus, and then we're going to do the horizontal or vertical distance rather of 9, which is going to give us 2. And so my coordinates are 7, 2. And we're going to see if this makes sense. Okay, so I'm going to box that as my final answer, but we're going to actually see if that makes sense in the context. So that means that my coordinate 7, 2, this is 7 and then 2 is right here. So far that looks like it makes sense because it has to be inside the line segment. If you're outside the line segment, then something is wrong. Remember, the point of this is to partition the line segment, to cut it. And so if we cut it here, right, at that coordinate, well then that's going to be 3/5 of the way from B to A. And let's kind of show you why that's the case. If we were to cut this into 5 pieces, let's try to cut it as best as we can. We have 1, 2, 3. Let's see, 1, 2, 3, 4. Here, I'll try to do this the best I can here. This is not very good. Okay, so 1, 2, 3, 4, right here. Okay, and that's 5 pieces. Okay, roughly 5 equal pieces. 1, 2, 3, 4, 5. And so if you look at this, well, this right here is 3 pieces away from B. And so that's going to be 3/5 of the way from B to A. And so we did this correctly. And this is the way you can kind of check your work. All right, so that's how we partition line segments. Like I said, it really depends on what direction the line segment is going, whether you're going to subtract or add. So really, if we go back to the step, really we could say that this is really plus or minus, and the plus or minus sign right here depends on the direction of the line segment. All right, so now we're going to talk about a very specific type of partitioning, which is called finding the midpoint. The midpoint is exactly the way it sounds. It's the middle point in a line segment. So if we were to take the line segment and cut it into 2 equal pieces where each side is the same, then that point where we slice it in half is known as the midpoint. So like I said, the midpoint is a specific partition that breaks it up into a 1-to-1 ratio. So basically it's half the distance, which is the same thing as a 1-to-1 ratio. So if I have a generic line segment from A to B, then if I cut this line segment, well then this is 1 piece, this is 1 piece, and this would be a 1-to-1 ratio, which in this case is 1/2 of the way from here to here. So we'll say that this is 1/2 of the distance, and that would be the ratio. Okay, but there's a very specific formula for this. So this is the midpoint formula. So you don't necessarily have to use partitions the way we used it before. You could just use this formula to find the midpoint. And so the midpoint is just the average. Notice that this is just the average. So when you find the average of two numbers, you add them up and divide by 2. That's exactly what you're doing here. You're doing the average of the x coordinates and the average of the y coordinates. Okay, so let's find the midpoint in the following line segment, AB. Okay, so using that formula, right? So we know that the midpoint of AB and let's go ahead and write down the formula. X1 plus X2 divided by 2, Y1 plus Y2 divided by 2. So you can call X1, X2 whatever you want, as long, as you can call either one of these X1 or X2, as long as you're consistent, okay? So if I call this X1, then this one right here has to be Y1. So this one right here has to be Y1. And then if we call this X2, then this one has to be Y2. Okay, so just be careful. Remember, the X coordinate is always the very first coordinate. So then we just go ahead and plug it in, right? So this is equal to, and so we have X1, so -3, plus X2 is 4 now. Divide that by 2. This is a very straightforward formula. All you gotta do is plug in the numbers. So we got 2 plus -2 divided by 2. And so -3 plus 4 is 1. So we really just have 1/2 here. And then 2 plus -2 is 0. So we got 0 divided by 2. But 0 divided by 2 is just 2, right? So this is going to be 1/2 and 0. All right, and that's my midpoint. So that midpoint is actually, if we were to plot it, is right here. And that's at 1/2, comma 0. And that makes sense. That breaks it up into 2 congruent pieces. All right, so that's how we find the midpoint of a line segment. So now let's talk about the last key topic, which is finding the distance of a line segment. And the distance of the line segment is just really the length of the line segment, okay? So if we find the distance from A to B, or in this case from P to Q, well then really we're just finding the length of the line segment from P to Q, or from A to B. Okay, so how do we go about doing that? Well, we use what we call the distance formula. And this distance formula is given by the formula below. So you're taking the square root and then you're subtracting the x coordinates. So this is basically the horizontal distance, right here. So it's the horizontal distance squared. Notice that this is just x minus x, and then this is y minus y. So that's the vertical distance actually. So if you take the horizontal distance and you square it, the vertical distance and then square it, and then add those together and then take the square root, you get what we call the distance. So let's go ahead and use an example with a word problem. So here we have a pitcher throws a ball to a batter who hits the ball to the shortstop. If the ball travels in a straight line between each, what is the total distance traveled by the ball? So here they want the total distance, which means that implies that we got to add at least 2 distances together traveled by the ball. Okay, so let's plot out the scenario here. So first off, the ball is going from the pitcher to the batter, right? In a typical ball game, baseball. So it's going here, right? So we got to figure out the distance from there to there, from P to B. So we'll call that P, and then we'll call this B. And the coordinates of B, let's go ahead and write that down. Well, that's going to be 5 and 5. That's the coordinates of P, of the pitcher. And the coordinates of the batter are 0, 0. All right, now let's do the coordinates of the shortstop. So so once the ball goes to the batter, well then it's going to go to the shortstop in this example. So it's going to go travel straight to the shortstop. And that's not a straight line, but it should be a straight line. So I'll go ahead and draw that a little bit better. Okay, so straight line, and then the coordinates of the shortstop are, in this case, 5 in the x and 10 in the y. Okay, so now what we're going to do is we're going to find the distance from B to P on the line segment. So we're going to do BP, and we're going to use the distance formula. Okay, so remember, if we want to find the total distance, we got to add the BP, and then we got to add the blue. So we got to add the orange and the blue parts, basically, to get the total. And let's call this point right here S for the shortstop. All right, so let's do BP. So we got to take the square root, and we got to subtract the x coordinates. So the x coordinates in this case are, 5 and 0. So let's call this x1. Let's call this x2. It doesn't really matter which one is what, like I said. The x, as long as you say the x is the first and the y is the second, and keep them consistent. So if we subtract the x coordinates, well, we got 5 minus 0 squared plus, and then let's subtract the y's. So y1 is 5, and then y2 is 0. So 5 minus 0 squared. And in this case, we got square root of 5 squared plus 5 squared. And 5 squared is 25. Remember, 5 squared is 5 times 5. So this is going to be 25 plus 25, which is 50. Okay, I'll write down the work here. This is 25 plus 25. Okay, so we got BP is 50. So now let's go ahead and do the shortstop from the batter to the shortstop, which is BS. So, or SB. BP or PB, or you could say BS or SB. So it's going to be the square root of, we're going to do the x coordinates, right? So x here, so it's going to be 5 minus 0 squared plus, and then the y coordinate 10, and then the other y coordinate is 0, so 10 minus 0 squared. So we got the square root of 5 squared plus 10 squared. We said 5 squared is 25, and then 10 squared is 100, so we got 125 here. Okay, so now what we're going to do, we're going to actually get these as a decimal, and it says round to the nearest tenth of a foot. So let's go ahead and calculate this. We're just going to put this on the calculator. We're going to do the square root of 50. And the square root of 50 is 7.07. But it says round to the nearest tenth. So I'm going to round. So first I'm going to round. I'm just going to round it to a lot of decimals. So to a couple decimals. And then later I'll round it to the nearest tenth. And then let's do the square root of 125. So that's 11.18. All right, so then the total distance is basically BP plus BS. And so we're going to add those two together. So 7.07 plus 11.18. You get 18.25, which we're going to round it to the nearest tenth. The nearest tenth is this decimal place here. That's a 5, so that means we're going to round that to 18.3, approximately. All right, and that's a word problem that involves distance. Now, this word problem has two distance formulas, basically. So we basically applied the distance formula twice to answer this question. And not all problems will be like this. Sometimes you'll just find one distance, right? All right, and guys, that is it for the lesson. So we went over the distance formula, the midpoint, and how to partition. So I hope you took something from this video, guys, and I will see you in the next one.